Hello, everyone. My name is Gabriel Lacayo. I'm a junior studying computer science games, and my talk is better programming in Unity. My main reason for this talk is it's for people that know how to do some programming in Unity, but may not be aware of a lot of the tools that are available in Unity for you to use, as well as hoping to convince people to have a better mindset with the code that they write. So I'm happy, I'm happy people are here, and yeah, let's just get right into it. Okay. Pull up the window 1 second. Okay. So can you guys see the screen and everything?
Yeah, we can.
Okay, awesome. So like I said, this is better programming in Unity, and let's get started. So I'm gonna start with the takeaways because I don't want you sitting here for an hour and not knowing what I'm saying. So these are the 3 main points that I want to make. It's basically get it working first, then clean it up, make something other people will use being very different in what that can mean. And then 3rd point, write as little code as you can. So these are all the points that I want to make over this talk, and I hope everything I'm saying can translate well. Yeah, so get it working first, then clean it up. What exactly does that mean? Well, pretty much it means you have to look at your job and basically understand how you fit into it. So this is from Luca Galli in a talk that he gave in 2014 at ACM. And this is basically a large overview of the game development process. Where programmers specifically fit in, I think, is in every part. Because usually with prototyping your game design and stuff, you usually need somebody to either script that or create new components for that or whatever. And the main motivation here is that you want to be a part of the process every step of the way. And so you're basically on the forefront of production for most of the time. Even in production, you're also doing stuff. You're creating new features or fixing bugs primarily. And then even up until release, you're always doing something. So that's pretty much what you would do. At least I haven't had professional experience. This is basically a good summary of what I've learned through a lot of different people and just online in general, is just knowing how to get stuff out the door, but then also do it well. So there's 2 steps here that I want to emphasize. Have something working, and then you redo it, right? So having something working, that's usually the hard part already, because your first iteration probably doesn't work, and then you have to go back and fix it, and it's kind of working. And then some edge case throws it off again, and then you have to go back and fix it. That's the whole process of programming, just always seeing if something works or not. And I mean, that's kind of what you're stuck doing. But even once you do get it working, I want to emphasize the point of redoing it, because that is going to help you a lot in the long term. Why? Because once you solve the problem once, you actually understand the question that you were trying to solve in the first place. A lot of what engineering can consist of is knowing what problem to solve. Literally just knowing what the problem should be, right? And how to express it. What are the constants, the constraints, anything like that. And then I think it applies to programming as well. So like some of the points here, knowing what not to do, right? If you knew what not to do, you wouldn't have done it in the first place. But sometimes you don't know just going into it, right? You come up with one thing, but then it might not always, it just doesn't seem right. You know, there could be some better solution out there. At one point on here, premature optimization. You really, like, a lot of people say you really don't need to optimize at first, and I agree with them. You shouldn't be thinking about runtime or space complexity or anything like that at first. You just want something working. You need some mechanic to see if it's fun or not. We just got to get that mechanic working, because the main point is seeing if that mechanic works, not if it's stellar code that just works in every case, because you can't do that in that small of a time frame, right? So even if it doesn't work completely, that's still fine, right? You just need something fast. And that's what prototyping is all about, whether in design or even like artists. Usually you do a quick sketch of what you're thinking, just so you can frame everything and how you want to see it. You don't worry too much about details, right? You don't you don't want to be shading what you sketched. You kind of save that until the end. And I think that applies to programming as well. You just need something quick and dirty and out the door. But then the second part to that is, okay, now that you have something, how do you redo it? I think the scope of this, with that first point, is as small as a snippet, as large as a system. So let's say you've arrived to having something working. You see if it's fun or if it's doing what it should, because not everything is a game mechanic. It could be something in the shaders with graphics or whatever. Now, like I said, now that you know, you have a better idea of what the scope of the problem is, you realize what the hooks need to be. And by hooks here, I mean the data that just needs to be accessed from other places. Something like public functions or public variables, something like that. You know what it needs to say to other scripts. And so you can keep those there, and then everything under the hood, you can start reworking. That's why if you see stuff in Java or C# with interfaces, that's the whole point of them. You understand what this type can do and what are some of the available functionality with it. But under the hood, you're not too worried about it. This last point here, chance to actually optimize. I would say you can still put off optimization here. Depends on how permanent this is actually going to be. And with code, usually nothing's permanent. But with so there's what's called a naive solution, which is pretty much like, say you had to search an item in a list. You can go and search every single item and check if it's the item. So if you remember runtime stuff, that'd be O of n. That's a naive solution, but it's a solution that still works, right? It'll still find if it's in that list. And so same thing with whatever you're implementing here. It'll still work, but there's likely a better solution. And now that you understand the problem better, you might have the intuition to follow a better solution to that, right? So that's pretty much what this first point means of getting something working and then redoing it. Okay, so here's one problem. What if I don't have time to redo what I just did, and it's going to take a lot of work, and this thing has to be done by the week because I have to turn it in, or that's when the deadline is, or whatever. So that's fine. But I would say for the next project, you do need to factor in the fact that you'll refactor, because it's just part of the process. Getting something working is, you could say, it's just half of the problem. Second half is actually making something that'll be better. What exactly does better mean? So this guy, his name is Uncle Bob. He has some videos on YouTube, and I think this one is really good. It's called Clean Code, and he basically expounds upon a lot of what I've been saying in terms of redoing code and making it better. He has the point of polite code, and polite is similar to what I'm doing with the slides, is walking away with the idea as opposed to the nuances. So in the same way that I put the takeaways at the very beginning, so you at least know what I'm going to say first, it's the same deal here. He gave the example with journalism. You basically have the headline, big, bold letters at the top. You have the synopsis, which is pretty much the first paragraph that gives the high-level details of what's happening, and then the rest of the article, which is actually the parties involved, what actually happened, stuff like that. If you looked at the headline, you already have an idea of what's happening. If you look at the synopsis, now I can at least express it more clearly, right? It's not just a couple phrases that you saw in the headline. And the details is actually, all the lower level stuff. So similar to journalism, code also has levels of abstraction here. You have a giant system and it has components to it and subcomponents and like each individual script. If you want to keep going down the level, it's buffers, types, pointers, whatever. So what I mean here is with polite code, it keeps that abstraction the same. It's easier if you would look at the video, but say you wanted to create a string, you don't have to worry about allocating the memory for that string, putting in the characters. You just want a string right here, right now, to like do whatever. So that's similar to the mindset you should have when actually programming. You don't want to keep going like up and down levels. You kind of want to maintain consistency. In the same way that you would write functions, you don't want them being huge, giant things that have a lot of what are called repercussions, which are basically its effects on the rest of the program. You want functions to be very bite-sized chunks that you can understand. Now, some functions could inherently be long, but you kind of want to find the balance between having one giant monolith sort of deal, then also having like a bunch of little tiny things every single where. Because say like there's some problem and you have to look at a function, well, you have to, read what it says, and then go into another function, and then go into another function, then another one, and you're kind of like all over the place. You want to avoid that and instead replace it more with, manageable chunks. When you read it, you just kind of go right over the words and you see what it says, right? Same thing with what I said here. It's basically like a little synopsis. Okay, are there any questions this far? You can paste it in the chat. I'm eyeballing it. Or if anybody wants to say something, you can. All right. What's up? Thank you, Richard. Thank you. Okay. So here's the second point that I want to make. Making something other people use. Yeah, I would say, I think the stereotypical programming part is just coding something and then the people on the other side just see that it works. I think you could say that's what's happening, but really the programmer has some needs to meet and they're trying to meet those, right? So the basic idea is you're the producer and everybody else is the consumer. And consumer here can mean designer, artist, programmer, just somebody who's using what you made. So if you wanted to put that into practical words, it could be the script that you wrote for a player controller. A designer is probably going to use that because they want to tweak the parameters that you created for the player. They want to access the state of that in some other script that needs to know, like, is the player jumping right now? Then I should be doing this or whatever. It could be artists with tools that you make. Depending on how they make the level, they may need some kind of tool that helps make that process faster. That could be another thing, or it could just be a programmer. It could be somebody down the line who sees that there's some bug happening and they have to go through your script that you made months back and figure out what's happening here. So all in all, you're always making something for somebody. And that's the mindset that you should have. It's not just, I'm the only one that's going to worry about this, because if you keep doing that, you'll run into, you're the only one that can ever solve this problem because nobody else knows what's happening with what you wrote. And if it's far enough in the future, you might not know what's happening in what you wrote. So this is where I can get into more specific Unity stuff. So such as scriptable objects, you have attributes, which is related to property drawers because they're kind of doing the same thing, kind of. And then editor scripts, which are basically just like one higher level above attributes. So scriptable objects. A lot of what I'm going to talk about right now and a lot of what I know came from this guy. He is God tier programmer, but pretty much he has a Unity conference talk about scriptable objects. And the whole idea of them is keeping data persistent. Who is that? I don't remember his name. I will look it up for you. If you click the link, or I guess you can't. Here, I'll actually just paste it in chat so people can check them out. And yes, I will make these slides available. You don't have to worry about that. But yeah. So his whole talk is just talking about scriptable objects. And whoops. There you go. And yeah, it's about keeping data persistent. And that can mean a lot of things, but that's the overarching idea behind them. And there's also the idea with runtime versus disk. So let's talk a little bit about that. So during runtime, that's when your game is actually running and the state of the game is changing. All the scripts are firing everywhere. They all have linkages to other scripts, what I here call references. All that's happening in runtime. And any changes that you make during runtime, those won't persist, right? They're going to go away. If you've ever used Unity and you were in play mode and you were doing something with some parameters or whatever, you have to remember that if you hit stop on play mode, those are all going to disappear, right? Which can be really annoying if you're trying to tweak a lot of little things everywhere, and then you have to either write down or just remember what you actually changed. You could do it piecewise with hit play, change this thing. All right, that seems good. Stop, and then put it down. That's very slow, but that'll work, I guess. Anyways, that's all in runtime, right? Because you don't want the editor to keep a lot of the changes that you make, because then the state of all your code stuff is now messed up. It needs to reset back to what it was before. So that's why you have stuff on disk. So art, audio, and here with data, that's where scriptable objects can come in. That data, because it's on disk, it'll keep its changes. If you stop play mode, it wasn't related at all with runtime. So the data it's just there, right? You wrote to it once and now it won't go away. So what does this mean in practice? One example he gave in the talk was with player HP. So typically, if you first wrote a player controller, you would have his HP as some public variable or some property, some getter setter thing. Anyways, just having it publicly available for other scripts to use. The issue that can arise later down the line is, say you have your audio system and you need to test something, but it needs a reference to player because it needs to pull his HP somehow. So if you wanted to test your audio system, now you need to bring in a player, and then you have to hook it up in the scene because it's not going to auto-magically reference it for you. But so now you're having your audio system, but now your player's in the scene. Oh, but your player also depends on some like level creation script, and now you have to pull that in, and then you start going down this rabbit hole of having your entire game in a test scene, even though you just wanted to test one little thing, which was the audio system. So the example here with player HP is these three systems all depend on player HP, but because you've now made that reference be on disk, you no longer have to worry about scene references and setting those up. In fact, you don't even need a player at all because they only needed player HP, right? Now you just saved on having to pull him in, and now you also saved on having to debug, or not debug, but test your systems using the player HP. Because while the game is running, you have access to player HP. You can just pull it up in Unity and then change the values. And then those systems should update real time because all they're doing is just reading some value. If player HP is just a float, they only use that float for their functionality. They didn't need anything else from the player at all. So that just makes testing a lot easier, and it just helps abstract your data out from the scripts that you wrote. And this goes back to the first point of rewriting it, because now that you know what systems need what, you can just put those into scriptable objects, and now your whole program is a lot more modular, right? You can take pieces in and out. You can change values on the fly. If you wanted to have all your player parameters in a scriptable object, you can be in play mode and keep tweaking it and feeling it and just iterating on that. And then those changes will persist because they're on disk, right? So in short, it just makes iteration faster and testing faster. And it's less headache to get something working. Because say you needed a new system that also had player HP as some dependency, well, you just set it up. And if it's a prefab, any instantiation of that prefab will keep that disk reference, and you basically don't have to worry. It's just less, like I said, less headache overall. So this next part, moving away from scriptable objects, is attributes. So attributes are what you see in green here. Those are the little bracket parts that go next to your member variables. They can go with other things like class and enums, but for now we'll talk about member variables. And they, specifically with Unity, they will determine how things appear in the editor and how they function as well. So here's 4 examples to start. You have space, range, tooltip, and serialized field. Space just adds some spacing in the editor. Range limits whatever you give it, between a minimum and maximum. So here for my float, you can see in the image how now it becomes a slider. If you didn't have that attribute, it would just be some number. And there could be a case where you have this float, but you really only care about values between 0 and 1. But you know that somebody else looking at the script doesn't know that from the offset. They just see just a number. You can put whatever number you want in there. And it could lead to something breaking because they just didn't know that this should be between 0 and 1. So range is a great one to use. It works for floats, ints, probably doubles, whatever's the number. Tooltip is also a very nice one. If you hover with your mouse over some things in Unity, it'll tell you a bit more information, and you can use that attribute to do the exact same thing. If you had some variable and you didn't want to have a giant name to describe what it does, you can just add it as a little tooltip. So if somebody was curious as to what this does, that's where you can give a little bit more description about it. In serialized field, this one's a little tricky to understand, but pretty much with programming, you usually want to keep data as private as possible because you don't want stuff messing with other stuff that it shouldn't have. And that's why you have these public variables and properties and stuff, public methods and properties. Serialized field with Unity, it'll actually allow the editor to look at that private data. And so that's how you can keep all your parameters hidden from other scripts. But then in the editor, where you know what you want to do with it, you can adjust values there. Here's a couple more. Header just adds what you see there. My variables is in bold, and it kind of outlines it in the editor, kind of demarcates it. Hide an inspector. That's if you wanted public data not to be visible in the inspector. That one's a little bit more rare to use, but it is useful if you wanted it public to code, but not to the editor itself. And then multi-line and text area are the top and bottom ones there. It just lets you write text more easily. The default one, which is my string, it'll just have this one line. And then if you keep typing, you'll just stay on that one bar, and it's just a pain if you have to write a lot of things. So text area multi-line just help with that. So these are some attributes out of the box. Going back a slide, if you check out that website, it lists some more. I'm sure if you just look RIP tutorial Unity attributes, you can find it. And then this relates to property drawers because it's how it's actually being rendered in the editor. So the attributes that come out of the box with Unity, they'll do all of this already because it's already made. But then you can create your own custom property drawers if you made your own attributes to give variables a new type of way to be displayed or modified or something. So here's one example, is a conditional hide. This is an extremely useful one because that motivation is lessen the ambiguity of what the script actually does. So if you enable or disable an option, things show up or they get grayed out. You don't get that out of the box, which is kind of ridiculous, but this is a user-made solution here. Here's the general thinking. If this thing is enabled, we should do something else, right? And so you see with the picture, all this stuff, you can visibly see that it's based on consumed resources. It's all visual. There's no like little description thing. There's no, you have to actually open up the script and see what's happening, because nobody wants to do that. That's bad. But you can just visibly see that if you enable consume resources, now you have access to all these little parameters that you can change. And similar to the auto aim, if you just had auto aim, then you can modify how that works. But if you didn't, well, you don't have to worry about it, right? It just makes life easier for the person looking at this in the editor, right? That's the whole point of the second section, is making their life easier. So editor scripts are now one level above that in basically changing how Unity will actually show your script. So here's another example, this touch object control. The image on the left is what you would do by default, or what Unity would do by default. It'll just show a lot of options everywhere, and it may not be very clear what's happening with what. The image on the right is what happens if you made a custom editor for it. Now, first, it just looks nicer, right? I think that's kind of an important thing, just making things look nice, keeping the aesthetics going. Like if you're just working, it just makes things a lot easier. That's why UI is always important in games, because it just adds to that game feel, making something feel nice. It's the same way when you're working in Unity. You want things to feel nice when you're using them. You don't want it to be such a headache, but this also supports just making something for others. If you made the script from scratch, you would basically know what's happening in the left image, right? It's kind of easy for you to understand. But say months down the line, you have to look at it again. Take some time, you'll probably get it back. If somebody random looked at it, they may not exactly know what's happening. So the image on the right makes their life a lot easier. It catches everybody up to speed. So back to the main gist. You're the producer, they're the consumer. Somebody's going to be using what you make, so you have to think about how they're going to use it. So this relates back to scriptable objects. It's a lot easier to debug and to iterate because you no longer have to worry about fixing broken references or just having data change once you exit play mode and stuff. It helps a designer's life. For tools, that helps artists' life because now they know what to do. You don't have to go over to them and explain what's happening. Instead, they just figure it out on their own. If they can't do it on their own, you need to modify what you did and basically iterate on your own script to deliver something, kind of like what you're doing with the game. You're iterating to make it more fun, and here you're iterating to make it more intuitive as to how to use your tool. So here's 2 points thus far. Get it working first and clean it up and make something other people will use. Right. Is there any questions for me to answer or something, want to comment on something? Yeah, I can paste the links later in the chat. That's no problem. All right, if there's nothing else, I will move on to the third point here. Write as little code as you can. So it's a little counterintuitive, but it's counterintuitive to what I've just kind of been saying, because it's I've basically been telling you to like write code, make stuff for other people. You could say the redoing thing and making it more polite contributes to this, but what I'm trying to get at is, why should you write little code? Because more money, more problems. That's kind of the whole ordeal with this. Is basically you have more code to sift through. It's trying to do too much. It's just all the code that you write is just a bigger mess to deal with, right? You know, not being polite. It's just harder to keep that whole program in your head, as well as explain it to somebody else. If you can keep it bite-sized and manageable, it's just easier to explain to someone and to fix problems, right? In engineering, the more parts something has, the more problems that can happen. That's pretty true of a lot of things, and it's no different with code. If you have a lot of things happening all at once, and there's multiple systems with multiple states everywhere doing different things, it can just be a pain to debug and fix something, or even just to create a new system, because now you have to integrate it with this monolith that you've created, and it's just a headache overall. So that's why it's important to redo what you wrote first, because you want to keep it manageable. And here it's saying the same thing. You're keeping it digestible since other people use it, right? If a programmer down the line needs to add something to your script, then it's so much easier if they can just look at what you wrote and kind of have a basic idea of what's happening. If you wrote 1,000 lines for something, oh, dude, there's no way nobody wants to look at that. So that's why it's important to redo it, because you want to make their lives easier, similar to how you're making designers and artists' lives easier, right? It's all kind of coming together with what I've been saying. You want code that works and that's easy to use, modify, iterate on, stuff like that, because your game and its needs are going to change as the project goes on, right? So you want to keep your code flexible and change with that. And it's easier to modify if it's small. It's also easier to modify if it's modular. And so that relates back to scriptable objects and property drawers, because now systems are more split, more abstracted from one another, and their dependencies are a lot more defined, right? It's so easier to see player HP as a scriptable object and then just see where it's being referenced, right? You don't have to, and it's only player HP, right? If you put everything in player controller and you find all references for that, you're gonna get a lot of different things, but they only need, all those scripts referencing it only need certain parts from player controller. So if you just did player HP, you see exactly what it needs and you know how to test it. It just makes life easier. And that's only with player HP. This can be for a lot of different things. The point of scriptable objects is supposed to be like very small, kind of like bridges between things. Yeah, so the gist is succinctness, right? You want to keep things polite, keep it very manageable to understand and to use. So Paul Graham, he's in the like tech world, Silicon Valley. He has one essay called "Holding a Program in One's Head," and the sentence here is pretty much, your code is your understanding of the problem you're exploring. So it's only when you have your code in your head that you really understand the problem. Back to what I said before with knowing what problem you're trying to solve. If you take this quote in mind, your code is a reflection of that. So the first step was getting it working. And now that you understand the scope and the problems better, you're able to redo it and have it be much more manageable and easier. And if there's less code, that's generally less bugs that you have to deal with. So all in all, it's about keeping your program very succinct and flexible because other people are going to use it. It's not always going to be you. So these are the 3 main points again. Get it working first, then clean it up. Make something other people will use, and write as little code as you can. So that's my talk. Also very short, but that's kind of the point. If there's any questions, now would be a great time to ask.
I have a question.
Sure, what's up?
Have you used scriptable objects? And if you have, can you give an example of what it was? I'm trying to visualize how they work in my head more.
Yeah. So one scriptable object was with player controller stuff. I basically kind of abstracted movement, constraints, type of jumps and stuff into a scriptable object. And so you could look at that file and modify a lot of different things during runtime and then just play with it. And those changes would remain on disk. There's another scriptable object. That talk I mentioned before, he has other examples as well. He has one called game events, which are very powerful because you start moving more into event-based programming. And I use those a lot because what you basically do is you have the scriptable object as an event, and then the script that has it, it'll just tell it to invoke. And pretty much what you do is you have listeners listening for that scriptable object. And if they see somebody has activated it, they will do other stuff. So what that means is the code that, okay, here's how I've always pictured it. Basically, your code is now just shouting to the world, and then it's up to the scripts over there to listen for what to do. So this can be extremely useful if your player hits a trigger. All you have to do is this trigger just calls this one scriptable object, say player entered door of building. I don't know, I just made it up. Now a lot of different things will respond to that, and you don't have to worry about this one door just managing all of that. Instead, it just invokes this one little scriptable object, and now everything else has to worry about listening for it and responding to what it does. So is that easier to, is that a good example?
Yeah, I think I understand more.
All right, awesome. All right. Any examples of games that have benefited from scriptable objects / error scripts? I don't know about other games. I know the one I've worked on called Embower. I was working on it, and when I learned about scriptable objects, I started to slowly incorporate them. It's when I used the game event one that was really amazing, because now you could set up a lot of functionality very fast, and you didn't have to write code for it. You didn't have to create game object references in your component, reference them, have some script on them to do something, stuff like that. Instead, it was all within the editor. I just told, hey, I'm gonna invoke this, and these other things just listen for it and respond. So I think that helped make something. And then if we wanted to design it differently, it was just a few modifications. And so I think that was very important to use. Next question. Since scriptable objects are writing to disk, would that add extra overhead in complex systems? So that's my thinking as well, because writing to disk is generally a lot slower. I think internally, Unity mitigates a lot of that overhead. Because I want to, this is something that I would Google because I'm pretty sure I did that in the past, but I think there's very minimal overhead with writing to disk overall. least the way that Unity has done it. I can't answer the question completely because I'm not entirely sure, but that's definitely something that I would look up. All right. So C# scripts keep your reference to the scriptable object that lies within disk. If you were to change the values of a scriptable object during runtime, you're essentially writing to disk directly. Is there a lag that happens until the value gets updated? So kind of related to the last question, there probably is a little bit of overhead, but the internal workings of Unity might mitigate that. So this problem would arise a lot more when you're doing what's it called? Oh my god, I completely forgot. Multi-threaded programming, because then you might come across race conditions and stuff. The talk that I mentioned before, he does go into more depth with that. So that's why I again recommend looking at that. But I believe what he said was scriptable objects allow for you to prevent race conditions from happening. And the lag that would happen, hopefully what you wrote for it isn't entirely dependent on there being an extremely small delta time between like writing the value and actually having it there. If you did run into problems like that, then maybe you couldn't rely on scriptable objects. I'm not entirely sure, just because I haven't dealt with it personally. Pog. All right. Anybody else have anything to say? I know my presentation is kind of short, but I think that's also a good thing because there's less time to walk away with the same thing. Yes, succinct. Here, I can work on sharing the slide here while people formulate questions. Let's see. All right, well, seems like everybody is okay. Oh man, this is not making it easy. Oh, here's a couple more. These scriptable objects become unmodifiable after the game is built. Okay, so yeah, it's basically how it works is when you build it, those scriptable objects kind of get put into the build. So you're not able to really change those values if you're running that build. I believe scriptable objects would only be accessible to you if you're using the editor and modifying the game itself directly. So what you could do instead is have a debug mode, and you still your code still references those scriptable objects. You can just no longer access them outside of the build, right? But you can still create debug code that will modify the scriptable objects for you, and that's how you can get around not being able to access them directly. Next one. Would you recommend storing things like game state in a scriptable object? Yeah, that would help. What could happen is you have a lot of state all held in one scriptable object, which could make it a little bit more complicated to see like what's happening. You could argue that because everything's in one place, it's a lot easier to see references to everything, because if they're referencing this file, then they generally need something from it. But yes, something like save data, that's a little bit different in how you want to use it, because typically you want to make sure people can't just modify that. Like if it's the worst case, if it's some text file and they can just write directly, oh, I have these items, do whatever. But yeah, scriptable objects, I'm not entirely sure. Like I said, I haven't personally done in-depth save states or game settings. So I think those would be a little different. Okay, I feel, sorry, this is an aside. I feel really dumb because I want to share these slides, but not just to USC people. But I can't find the way to do that, especially while I'm like looking at chat as well. What's the most challenging game dev challenge you have faced? This one's a little bit more, I guess, related to game dev stuff, but it's just overall productivity stuff. Something with like doing assignments or, I don't know, buying groceries. It's always like, I don't know, at least for me personally, it's always like something to like motivate me. It always feels a little bit less. So that's also related to game programming and stuff. Yeah, that's like a whole productivity deal, which is not directly related, but I still think that's prevalent for a lot of people. Is just how do you stay productive, especially now that you're just. Well, I'm like just stuck in my room for most of the day. It can be a little difficult to just always find that discipline to keep working on what you need to be doing. But yeah, I think just starting small and making a little bit of progress every day helps. At least for me personally, that's what I experience. I'm really not taking that many classes. I'm just taking 4, and that's it. That's like what I wanted to keep doing. Let's see. Thank you, Sean. Oh, here we go. Let me put it back out over here. Yeah. One thing I do want to say, so Embower, which was the that was a Unity project I was working on for a lot over the summer. It's also on my website. Well, but that was kind of the largest game I've worked on this for, because everything before that was maybe just for a game jam or just for an assignment in a class, something like that. But Embower was it was the largest thing I had to work on, especially because I just had to go through a lot of systems and maybe change how they were working before. Just because I wanted the experience of trying to make a game from the ground up, basically. And just for me to personally know what's happening behind the scenes and stuff. Yeah. Yeah, I could probably stop sharing my screen now. It's not necessary, but yeah. Let's see. Oh, there's a couple other chat stuff. Yeah, it's called a conditional hide. That one is very nice because, like I said, you see in editor what's allowed and what's not. How did you learn all these secret Unity magic tricks? Just like complaining about something and seeing if there's an answer online. A lot of what I learned is just with Google, as well as just watching talks and stuff. I just do that as a fun thing, like the game architecture one. That one especially was very eye-opening because there's not really tutorials that teach you this. If you're learning Unity, nobody dives into scriptable objects and attributes or anything like that. Instead, it's just they focus on getting something working and something like, something visible, tangible that you can see. They generally don't think down the line, how should this look? And because you're still inexperienced, you don't know how it should look. You're still learning how should it just work, right? So a lot of that initial learning, you kind of miss better guidelines to follow. So that's why, like I said, that's the motivation for this talk. It's because I wanted people to realize that there are other ways of solving a problem, and it might alleviate issues that they run into to begin with if you keep applying the basic knowledge to more and more problems, pretty much.